as we've done with some of the other proofs, I'm going to start by just changing the statements of congruency to the measures equal so that I can replace them. In this case, it's segments, so definition of congruency with segments. Knowing that definition of congruency means, all the measures are equal. So if there's only one measure for a segment, that one measure could stay would be equal. And that way we can use the replacement rule with it. Looking to use segment addition, I do have a couple angles I can name. But in this case, if you look at what we're given and what we're trying to prove, mostly dealing with segments. So I'm going to use segment addition postulate because they don't give me anything specific. So at the least, I can say the two smaller segments add up to the larger segment. And there's a couple different smaller sets that I see. I see TS, and I think if I combine that with SR, you would get that whole bottom length. So TS, SR, combine those, you're going to get TR, and then the one going straight up and down, PQ plus QS equals that whole segment going up and down, PS. Segment addition postulate. We've got a few equations, and hopefully we'll be able to replace those together and get PS equal or congruent to RT, which is what they're asking us to prove. Looking at what I have and what I can replace, I don't have the same total yet. I'm looking up, they don't tell me those are the same total. So what I'm going to try to do is maybe get the sums the same. If you look at what we're trying to prove, that's actually the total. RT is a total. Well then, if I can show the two sums are the same, that means the totals have to be the same. So let's just rewrite one of these equations. It doesn't matter which one. So I'll just pick, I don't know, we've done the first one often, so maybe it'll work out well here, but the better you get at this, the easier it is to look ahead and see which one would work out best. So let's just see what we can replace in that first equation. Can we replace TS with anything? Well, I don't know if you know this or can tell, but TS and ST are the same thing. So it's just named differently, and that's equal to QS. So let's replace that with QS. If you keep going in that first equation, SR, well, that's the same as RS again. I know it's named differently, but it's representing the same value, so that value can be replaced with PQ. So I rewrote that first equation. If you look at what we have now, these two statements look pretty close. Those sums are pretty close. If I can show they're exactly the same, well then PS and TR have to be the same. Well, I think all that's left to do, I'm going to take that equation and go one step further. I just replaced. This time I'm actually just going to switch the order that I'm adding. That's CPA. Remember doing that in several of our algebraic proofs that we started off with. You might see now that these two are exactly the same except for what they total. Well, I can rewrite this, and I'm just going to keep going with the one I have. I think it'd be easier to follow, and we'll just see if it works out the best or not. But I'm going to replace something again. Here I want to leave the total, TR. That's kind of this RT that we're trying to get to. But instead of PQ plus QS, look at what else PQ plus QS equals. That's the measure of PS. So this time I replaced the sum with the total. In the other proofs we've done, we replaced the total with the sum. So looking up at what I'm trying to prove, those are the same two values. They did end up in the right side of the equation or the left side of the equation, wherever they were supposed to be. Just a matter of changing them to congruence. If they did need to be switched, we would have used symmetric property. But as it is, we won't need to. So I used replaced in step 6, and by definition of congruent segments was able to change them to congruent to finish this one.